A club, I'm talking drink, dance, smoke, freak, party all night. Come back, go aside. Leave it.
And does that surprise us with Taylor, with how long she did?
Open your heart, I'm coming home.
That's what a repaired Rittenhouse Model RM20/RM22 sounds like after it's been rebuilt. It was just about 2 months ago I posted a video where I did sort of a quick look at a Rittenhouse Model RM20/RM22 radio intercom master station, and I will put one of those pop-up things up here so you can go look at that video too if you want to. After that video was out, I was contacted by a fellow named Martin, and Martin lives in North Carolina, and he bought a house about a year ago that has this Rittenhouse RM20/RM22. Now, the thing about the model number is, and what I think I've learned, is that the difference between an RM20 and an RM22 has to do entirely with the finish of the unit. This is Martin's unit, which is brown with gold trim, and these panels had sort of a goldish tone to them. The one I did in the other video is black with silver panels and silver trim. I don't know which is which exactly because I haven't found a catalog yet that says, but one finishes an RM20, I think, and the other is an RM22. So Martin says that he thinks his Rittenhouse intercom is pretty cool and he wanted to get it repaired. Before he contacted us, he actually sent it off, the entire system, because I have all of his stuff here. He sent it off to another company who was a, quote, specialist in Rittenhouse intercom equipment. They had it for about 6 months and then contacted him and said, oh, we can't fix it. It's got too many things wrong with it, and it's one thing after another, and we're going to send it back. And I think Martin was somewhat disappointed. So then he found us. I don't know if he found us because of the other video I posted or just in general, but he wanted to know if I was willing to take a crack at it and look at it and see what I could do. I said, sure, because it's always fun to work on something that's new and different. It is kind of a cool intercom. I know a lot more about it now than I did when I made the other video, because once you get into the nitty-gritty of fixing things, you learn a lot. This video is really about sort of what I've learned about these, because I think I always assumed that these were a relatively common model, and I don't know, maybe they were, but they're older now, and I don't know how many of them are out there, and I don't know how many of them actually work. So this one is from Martin's house, was built in 1968. So this is probably a 67, 68 set. Let me show you what I've learned about it after working on it. The first thing about this set, or any set like this, the very first thing that I noticed, and I noticed it somewhat on the one that I own, but even more so on Martin's, is that it has these 5 switches down the front of the master. So you've got power on and off, you've got radio, which can be AM, off, or FM, standby stations on or off. Haven't figured out exactly how that works yet. You have master speaker volume, which is low, off, or high, and door for door stations off or on. And then you've got a volume control, a tone control, your intercom switch, and your 2 tuning dials, separate AM and FM. These switches are very important because they control all the basic functions of the system, and they have to be in good working order. These are the switches that came out of Martin's set. There are 5. These are not in good working order. In fact, most of these are so incredibly worn and so incredibly worn out that you try as hard as you can and you can barely move them. That was one of the very first things that I checked and I noticed, because if these switches don't work well, the set's not going to work properly. These, you would think, are just standard run-of-the-mill slide switches, which they kind of are, but kind of not. These were probably standard run-of-the-mill slide switches from 1968. Finding replacements for them was a little tricky because there's lots of things that you have to consider. These switches gets soldered onto what I'm going to call the front panel circuit board. Now, these are the boards out of my set because I didn't want to do this with Martin's set. As I fixed it, I needed to focus my attention on fixing it and not making a video about it as I go. That's for later. So this board is this board. You've got the intercom switch, the tone switch, the volume control, and the 5 slide switches go down this side of the board. Whatever you choose, they have to fit onto the board properly. Move this wire out of the way. For instance, this one would sit like that. So whatever you choose, there's a lot of considerations on picking new switches because you have to find something that is very close to the same physical dimensions as this. It has to be the right kind of switch. This is a double pole, double throw switch. And this switch is actually interesting because if you look on it, you'll see there's 5 legs. So you've got 4 across this side and 1 up here. This one up here actually doesn't connect to any part of the interior part of the switch. It's not a switch leg per se. It's mostly a support leg. So when you mount it on the circuit board like this, because it's a fairly big switch and people are going to get their big paws on it and slide it back and forth and not be particularly careful, it gets soldered onto the back here and it helps steady the switch as it sits on the circuit board. You're never going to find switches made like this. This is very specific. Perhaps these were even made for Rittenhouse back in the day because they were a big enough company that they could have a switch company make them a switch that was what they wanted for their application, not something that was generally available to the general public. I don't know exactly how that went, but it could be something like that. So when you choose new switches, they have to function as the right type of switch. There are actually 3 different kinds of switches, and they have to fit the holes in the board as closely as possible, not just the spacing for the legs, but also the height of the total height of the switch as it sits on the circuit board, because it has to fit up against the back of the faceplate here, and also the stems of the switch, the black part that you slide with your finger, they have to protrude enough so you can actually slide them once it's mounted back in it. So there's a lot of consideration that goes into picking out switches. The other consideration, in my opinion, was that I wanted to buy switches that were of good quality, quote unquote, name brand switches. So I went to my go-to company, which is Switchcraft. They still make switches like this, not a huge number of them. These type of switches, because they're kind of big and bulky, and especially these would be PC mount switches because they solder onto a circuit board, where a lot of switches like this nowadays are panel mount switches where it would get screwed to the back of a panel in some way or another. The selection is somewhat limited. So I searched and searched and searched, found Switchcraft switches that were the right size, mostly, and the right configurations, and ordered them. They were not inexpensive. You would think of something like this, you would pay, $1 and change for. They were a lot more than that. So there's that. And then, to make it even more exciting, they didn't fit the circuit board precisely. So there was a little bit of modification to the circuit board to how they mount to get them lined up correctly and soldered in, or wired in quotes, to make them function correctly. You always learn a lot on the first one. The next one will be much easier to do because now I have sort of a routine that I can follow and it will go along much faster. Once I got the switches replaced, then the next thing that I found was the tone control. So these knobs come off. I'm going to take off the top one here. It's kind of hard to get off. Maybe I won't. So these are regular potentiometers, and they have plastic stems that stick out, which you can see here, and the knobs fit on the stems, and these protrude through the faceplate like that. So this one down here, you can see the stem is broken, and I actually have it. It's right here. And it's been broken for a long time, and someone attempted a repair on it at some point because they put, it might be kind of hard to see, but there's this little piece of like wire stuck into the end of it, and then there's glue residue. So somebody embedded a piece of wire into this, drilled a hole in the other side to reinforce it, tried to glue it back in place. It was a good attempt. Somebody made a good effort on it at some point in the past, but because it's a twisty knob, it puts a lot of force on the repair and it failed. This one is actually the one from Martin's set because it was broken, and I robbed one off the board for my set to put in his set to fix it because his needs to work, and this one I can play around with when I have more time. Initially, you know, these are potentiometers. They're volume control pots. So you would think, oh, that's easy. That's not a big deal. You just find something that fits onto the board correctly and it's the right rating and put it in and you're done. That's not necessarily the case. So stamped into the body of each of these has the manufacturer's name. They were made by a company called Stackpole. And Stackpole's still in business. Now they go by SPE, Stackpole Electronics. They don't make volume controls like this anymore. They make all kinds of resistors and things like that, but nothing like this. It's a name that I'm pretty sure I've heard of before, although I don't think I've ever used any of their products or repaired anything with their products in it before. You figure, well, it's got a model number, you know who the manufacturer is, so you do a quick Google search and see if you can find somebody who's got a bunch of like new old stock ones or something you can buy and you solder it on the board and be done with it. That's not exactly the way it went. So it turns out that Stackpole potentiometers, especially in the 60s, were very popular and used in a lot of well-known electric guitars, including like Fender and Gibson and other companies like that that you would recognize their names immediately. And because there's a lot of vintage guitar enthusiasts in the world, their parts sell for a lot of money. Even used ones sell for a lot of money. Now you would think something like this, newly made today, you might pay $3-4 for it, maybe $5 in a single quantity, something like that. Not a lot of money for what it is. I looked online. There are people who are asking and selling used ones for $60 and $80, and there are people that have new old stock ones that they want hundreds of dollars for. Now, those are ones that were primarily used in guitars, but of course, because these are related to the guitar ones, anything like this gets raised up in price also. And I didn't find any of these exactly. The ones that are used in guitars are chassis mounted, not circuit board mounted ones, because they bolt onto a plate in the guitar and then they're wired in. I didn't find any exactly like these, but even if I did, I think they would be really expensive, and that makes repairing something like an RM20 a really expensive proposition if you have a bad one. So cost of some of the proprietary parts for a set like this, the potentiometers and the slide switches, helps raise up the cost of fixing one of these, although we'll be on the lookout for them because maybe these would be less if you actually found them. I don't really know. So that's another thing I learned about this. The other thing I learned about this, just sort of in general, is while this seems to be a reasonably well-made set, it is a design from the, let's say, mid-60s when it was designed, and the quality of some of how it was built is very typical for back in those days. They are properly made circuit boards with solder mask and all of that. There are no component designations, but silk screening wasn't as common in the 60s as it was later. The other thing about these are basically Bakelite or phenolic resin circuit boards. They're not fiberglass, they're not FR4 boards. I don't even know if FR4 boards existed in the 60s. They probably did, or FR something boards. But these are just sort of standard Bakelite phenolic resin boards, which made modifying the mounting points for the switches easier, but you have to be careful because they're not the sturdiest circuit boards in the world. So you have to be careful when you work on them, and also you have to be careful when you solder on them that you don't lift traces and things like that. Although most of the solder connections and pads are pretty chunky, so that holds in pretty well. This one down here, because of the way it mounts, there are actually cracks in the traces because the mounting screw goes through this hole here, and if you over tighten it, it could stress the board, or if you drop the set, and it created, so we bridged them, and I was able to do that. So that was in the last video. But anyway, so there's that. The other thing that's interesting, this is a fairly simple design. The amplifier and intercom board, which is this board, it has a total of 3 whole transistors in it. This is the big TO3 output transistor, and then there's 2 little transistors down here. It's a very simple design with some interesting aspects to it. One of the things I like about it is, and I think it's a Rittenhouse thing, is there's a lot of attention to detail that they easily could have not done and nobody would have cared. For instance, here on the AM and FM tuning dials, you see these little slots right here, and I'll hold up my faceplate because you can see them better. Little slot here, little slot up there. These are little indicator lights that when you turn the system on, these glow red, and the idea would be that they glow enough that if you were tuning the radio at night when the room's kind of dark, you can see what you're doing, which is a nice touch. If they hadn't put that on here, I don't think it would have affected people's choice in buying this or not. It's just a nice little thing. The way it is designed, it uses, on the back of the faceplate, I'll put this back together here real quick so you can kind of see what it looks like. On the back of the faceplate, there's a little lamp assembly, and there's 2 sockets, and it's wired in, and so on and so on. It's got 2 little screw-in lamps. Now, the screw-in lamps, of course, were out. They had failed because it's like 60 years old. When I took them out, it's a little miniature screw-in light bulb. Most miniature screw-in light bulbs, somewhere on it, stamped or printed on it, will be the number of the bulb. These bulbs only say H40. I don't know what H40 means. And when you Google it, it's really hard to come up with any kind of useful information, because in the world of miniature lamps, there's probably 100,000 different ones. And they have to be the right style of lamp, the right size, but then also they have to be the right voltage, and they have to have the right amount of lumens in many applications. In this one, it's not done that way, and we'll talk about that in a second. There was sort of a search to try to figure out what these actually were, because there's no documentation that says what they are. With the little bit of information that I had, I Googled and Googled and Googled. Based on the dimensions of it, I was able to figure out that it's a T3 bulb. It's a 1/4 inch screw-in base, also referred to as an E, like Edward, 10 base. So that got us close, because at least that narrows the search down into a specific style of bulb. And then the choice was which one, because there's hundreds. Little miniature bulbs like that you can buy, and it has mostly to do with the voltage. You can buy them that run on voltages, could be as little as 1 volt or as much as, yes, 120 volts, because it's just the way the bulbs are made. So my genius idea was that I would simply take Martin's set, and I sort of Frankensteined it on the bench to make it actually work. And my idea was I would simply take the bulbs out of the sockets because they had both failed. I would power the set up. I would probe down onto the sockets of the lamp holders to see what kind of voltage was being supplied to them. And based on that, I can make a reasonable guess at what the voltage of the bulbs should be. It didn't work out that way exactly. Now, you would think, and you would assume, and it would be normal to make this assumption, that when you flip the power on, the switch powers up the set, and it also powers up the indicator bulbs, because that's how most equipment like this would be designed. You simply turn it on, supplies power through the set, and the bulbs turn on. That's not the way this works at all. This works completely differently, because when I was probing for voltage, I was getting almost no voltage at all, which didn't make any sense to me, because it's like, come on, you turn on the switch and the bulbs light up. It should be simple, but it's not. The bulbs are actually powered not by the low voltage transformer that powers the RM20 through the on-off switch, but the bulbs are actually powered from the amplifier in the set. And it's like, what? Now, immediately what I thought, I'm going to try not to get too geeky here. Immediately what I thought about was, why would they do it that way? There must be some advantage to doing it that way within the basic design. Otherwise, why would you bother? Because you simply could wire the two wires from the sockets into the circuit for the on-off switch, and when you turn it on, the bulbs light up. So why would you do that? Because there must be a reason why. And Rittenhouse, I think their engineering was done well enough, and they were clever enough about what they designed based on other sets I've worked on, that there has to be a reason why they would do that. So the two things that came to mind for me right off the bat were, one, if you tie the lamps into the amplifier circuit and essentially they're being powered from the output transistor in the amplifier, they could be using the output transistor as sort of a pass transistor to stabilize the voltage to the bulbs. But that seems kind of silly, because you could simply wire the bulbs into the on-off switch and choose bulbs with the right voltage, and it would be the same thing because it's a light bulb. It's not a critical thing. So that didn't make a lot of sense to me. So the other thing that occurred to me was, and this is where we get a little more geeky maybe, is it reminded me of a long time ago, I had an audio oscillator. It was really old, tube set, that had a light bulb in it. This is like when I very first started, like 35 years ago. And I remember when I bought it used, and I wanted to rebuild it. And when I took it apart, there's like, why is there a light bulb in there? And it wasn't a light bulb to light anything up. It was just a light bulb in the circuit. What I learned all those years ago were that was a fairly common type of design, originally done by Hewlett-Packard in one of their audio oscillators. I think it's a Model 100 or something. Because light bulbs, or lamps, are what are referred to as non-linear resistors. And what that means is that the filament in a light bulb has resistance, but when you apply voltage to the light bulb and the filament glows, brighter the bulb, the hotter the filament, the higher the resistance, but it's not linear. If you apply 1 unit of voltage to it, you get, let's say you get a resistance of 10. But if you apply 10 units, if it was linear, you would have 100 units of resistance. It's not linear. So it's a non-linear resistor. And there's advantages to doing that in things like audio oscillators and things like that. So then I did a little bit of looking into it, because I am not an amplifier designer. I'm just a guy who fixes them. There are cases and there are designs when amplifiers use non-linear resistors to help stabilize the output of the amplifier. And I think that's what Rittenhouse did. To really know that for a fact, because I don't have a schematic for this unit, what I would have to do is sit down and take the amplifier board and reverse engineer it, draw and create a schematic to see exactly what it's doing. But I have a feeling that's what they were doing. That kind of fits what I see in the set, and also in some respects it matches the cleverness of the people at Rittenhouse, I think. Anyway, that's another thing that I learned, which I found interesting. For most people, it's like, what? As for the rest of the repair, it was pretty typical. A lot of parts, a lot of old parts from the 60s. Some of these parts in here are newer parts. They were what was sort of tacked in by the other company. They were all removed and done properly. So, the other thing that Martin sent me was, along with his RM20, was his 5 inside remote speakers, which looked like this. This is mine that I own. I have 3 of these. You saw these in the other video, at least one of them. And these are the ones he sent me. And since he sent me everything, I went through and carefully cleaned the controls. This is the intercom switch. This is the volume control. And you have I think it's a 4-inch speaker on the back. Playing the intercom controls. The intercom switches, especially from when these were made, these are very high quality switches, which you see a lot in the 60s. Volume controls are volume controls. These are not stack pole volume controls. These are some other type that don't have a name on them. They're just sort of regular panel mount volume controls, so that's not bad. And the speakers are the speakers. This is a 5, and then I washed and cleaned. I took them all apart, washed and cleaned the faceplate, got all the dirt and grunge off of it, touched up the gold trim a little bit to make it look a little nicer, and put it all back together, cleaned the knobs and do all that kind of stuff that we always do. And then when all 5 of them were done, I tested each one individually. So this type of design, and this is another one of those Rittenhouse-y things, it's got this big Amphenol plug on it, which has 2, 4, 6, 8 pins on it, and it's key, so you can only plug it in one way. It has this sort of wiring harness that comes off of it, and that's where all of the wires from the remote speakers get connected. So if you have 5 remote speakers, there's going to be one color of each wire in the harness plus the number of speakers, so you'd have 6 yellow, 6 green, 6 white, 6 red, 6 black, and they all just get spliced onto the ends of those wires. There's no terminal strip, screw connections, none of that kind of stuff, because I think this was a more moderately priced system. So I think they were, one, trying to keep it small, but also trying to make sure that they could sell it for the price they wanted. So what I did was, this is my harness because Martin's harness is still at his house, and I had my one speaker already connected up to it. So the other thing I did for testing, which made it easier, was I sort of duplicated the color in a harness that I made, added it onto the plug connections, and that gave me a point where I could hook up each of Martin's speakers and test it to make sure that they all worked, and they did, which is really good. The other thing about this system, so the speaker cones in the remote stations, these measure at 20 ohms, which is weird. 24 is probably more common, so don't know exactly. Again, no schematics, I don't have any documentation to verify what they're supposed to be. The speaker cone in the Master Station measures 4 ohms. So it's unusual in my experience to have different impedance speakers within the same system. And then the other thing that Martin sent, and we'll talk about that again in a second, the other thing that Martin sent me were 2 original Rittenhouse door stations. Now these were in his house when he bought it. They have been removed permanently. They're not having door stations. The other one, they're both they're aluminum and they're old. So it does have a switch. It says push to talk. It's a spring-loaded switch, which kind of works. But like most of these kind of designs from those days, it's all very corroded on the back. And someone has replaced the original speaker cones, and these are 8 ohm cones, and I don't know if that's actually right or not. And I have a feeling, based on the wiring, that when you turn the door stations on here at the Master, these play music, I think. I don't know for sure because this is so corroded that it's hard to say, but I have a feeling that they do. So I'm going to work on this, and when I get my RM20 rebuilt, then we'll see if we can fix this up and make a test setup and see what happens with that. The other thing about this design, which I find interesting, this is what I would refer to as a transitional design. What that means for me is parts of the design are similar to what you see in vacuum tube intercoms and vacuum tube amplifiers for systems and solid state designs. The way this works is this board uses an audio isolation transformer, which means that the amplifier is sending the amplified signal to the primary side of the transformer, and the secondary side of the transformer is what drives the speakers. And that's the way it's done in tube amplifiers, because speakers are low impedance and tube amplifiers are high impedance, and they don't like to drive low impedance devices like speakers. So you put an audio isolation transformer in between, so the tube amplifier drives the primary side, which then induces into the secondary side and drives the speakers, so they're electrically isolated, but the sound still goes through. That's the way this is done also. There's an advantage to that because you can have different impedance speakers because the audio isolation transformer doesn't care. And also it means that the amplifier is not working as hard as if it were driving the speakers directly. So it's like this thing is running and cruising in third gear on the freeway all the time. It's not working really hard, and that's why they can get away with, and this is a 16 volt system. It uses a 16 volt transformer, and as near as I can tell, the original transformer that came with it was 16 volts rated at 15 watts, which is not a very big transformer. You don't need a giant transformer to power the amplifier because the amplifier is just cruising along. It's got an easy life. It's going to last for a really long time, and it's probably going to be pretty trouble-free. So all in all, it was a good repair. It was a good learning experience, and there you go. I will make some follow-up videos about cleaning the controls and the remote speakers. I've got to get my RM20 finished up. I have to order some parts for it, and then we'll deal with the door speakers, and there'll be some follow-up videos on all of this. But I think Martin, we talked to him yesterday. He's excited about getting his system back and putting it back in. All in all, it's a nice little intercom. It turned out really well, cleaned up really nicely. We sort of touched it up to make it look nice for him and all of that. So that's an Rittenhouse RM20/RM22 radio intercom master station. I'm going to have to say, someone else who's supposed to specialize in these things said it couldn't be fixed. Ha! Okay, I hope you found this interesting, and perhaps for someone it will be helpful. If it is, give it a thumbs up on YouTube because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.
She grew up in an Indiana town, had a good-looking mama who never was around, but she grew up tall and she grew up right with them Indiana boys on an Indiana night.